Assalamualaikum warahmatullahi wabarakatuh. I would like to say thank you for watching my presentation today. It's great to see you all. Let me introduce myself. My name is Sekarsari Utami Wijaya. I'm from UIC. Today, I will discussion about the warehouse design under class-based storage policy based on entry item quantity analysis case study. The authors are Sekarsari Utami Wijaya, Rahayu Johana, and Muhammad Faisal Ibrahim. The outline are introduction, method, result, and discussion, and the last conclusion. In practice, every trade tends to have a whole uncertainty about demand. It has encouraged the trader to make policies about the inventory systems. It aims to anticipate unpredictable demands. The policy about inventory system prompts traders to provide a facility that will be used for a warehouse for storing goods. A warehouse is a facility used as temporary storage place for goods before being distributed to end customers. These goods can be raw material, work in process, or finished goods. Warehouse play an important in maintaining the suitability of supply to demand in supply chain system. Some of problem in warehouse system is are difficulty in moving goods, then accumulation of goods, long searching for goods, lack of capacity. So for this problem, so we need the appropriate warehouse layout design. So it means that warehouse system is the it has an important role. So today, in this study, we will two method. Yeah. The first method is the class-based storage method. This method is used to design the warehouse layout in order to maximize the warehouse utility as raw material storage. The class consists of three classes, such as A class, B class, and C class. And the other method is entry item quantity analysis. This method is applied to further analyze frequently ordered product so that it can support the distribution center layout. We use four indicator in entry item quantity analysis, such as IK analysis, IQ analysis, EN analysis, and EQ analysis. The problem in this study, we have UD-XYZ. UD-XYZ is a distributor that sell many kinds of material for roofs. The material are consist of roofs, tin roof, asbestos roof, roof ridge cap, film roof, and spandex roof. UD-XYZ has a problem. The problem such as accumulation of goods. Because the pile of goods that are too high make it difficult to withdraw goods. Lack of capacity, minimize capacity because storage goods disorderly. Moving goods that spend a lot of time causing high costs in material handling. And the last problem is long searching for goods. Delay occur due to the length of time it takes to search for items. So, the objective of this study, there is two objectives. The first, this study consider determining the number of racks needed by entry item quantity class-based storage analysis. And the second, this study will compare the warehouse layout based on EK, IK, IQ, EN, E, and EQ. It aims to obtain the best improvement in the warehouse layout that has the smallest expected distance for UD-XYZ. So there is some methods. Exactly, there is 5 steps. The first steps is classify goods using the class-based storage method based on IK, IQ, EN, and EQ. And the second, design shelving storage rack. The third, calculate the number of rack as storage. The fourth, design warehouse layout by racking system. And the last is calculate the expected distance. We can see the existing warehouse layout UD-XYZ. As the picture, the total size of UD-XYZ warehouse about 260 meters square. Its length is about 20 meters square and its width about 13 meters square. Only 110 meters square of total warehouse size is used to storage the material. The existing warehouse layout design shown figure doesn't consider the distance between the aisle in every location of materials. For the first steps, we must classify goods using the class-based storage method based on the IK, IQ, EN, and EQ. There is a table. From the table, we have information about the number of material ordered in Class A is the smallest because the proportion of Class A about 1% until 20% of accumulated percentage. Class A materials shall be stored in rack near from access door. Class B materials shall be stored in rack between Class A and Class C. The highest number of material ordered is in C class because the proportion of Class C about the smallest 50% until 100% of accumulated percentage. Class C material shall be stored in the common rack due to weak flexibility. And the second steps, design shelving storage rack. There is two storage. There is a two rack. Type 1 rack. It's are used to store roof and roof ridge cap, and it has 2 level and height between level about 1 meters. The dimension are 1 meter and 1 meter. The thickness of board about 5 centimeters, and the capacity is 100 items of roof and 150 items roof ridge cap. And the type 2 racks, it's used to storage in tin roof, asbestos roof, film roof, and spandex roof. And it has 3 levels and height between levels about 0.5 meters. The dimension are 2.2 meters and 1.1 meters. The thickness of board about 5 centimeters and capacity 100 items. And the third steps is calculate the number of rack as storage. As we can see in the table, the material in the warehouse will be stored in rack based on the class-based store method. The stock of material is used to determine the number of racks. According to the calculation, the warehouse will provide 14 types 1 racks and 13 type 2 racks. The area is need about 45.46 meter square. The total area of UD-XYZ about 160 meters squares. The area on UD-XYZ can provide the area required. And for steps is design warehouse layout by racking systems. There is layout based on IK analysis, IQ analysis, EN analysis, and EQ analysis. For this layout, we can calculate the number of rack and capacity. In the table, we can we can get information that IQ analysis and EQ analysis has the same number of rack and the same capacity, and the minimized number of rack and the minimized capacity. And then for step, we must calculate expected distance with the Euclidean distance. For this table, as we know, the smallest expected distance, the best warehouse layout design. So IQ analysis result is the best warehouse layout design, because IQ analysis has total expected distance about 138.32. So the nearest expected distance can affect the time for material handling. The material handling in IQ layout designs is more effective than others, and also it can affect the cost. Its cost will be more efficient than others, so that the warehouse layout design proposed to UDXYZ is the IQ analysis warehouse layout design. So the conclusion, warehouse storage is an essential step in the logistic process, which directly reflect the status of material before in circulation and serve as the basis for the company in evaluating the materials, products, and sales. Based on the analysis that has been done, the warehouse shall provide 14 types 1 rack and 13 types 2 rack. And IQ analysis result in the best warehouse layout design, so that the warehouse layout design proposed to UDXYZ is the IQ analysis warehouse layout design. Thank you.